Hey, right. So, hello and welcome to the channel. Apologies in advance because this is a very dry topic and I don't know how else to communicate it. But today we're going to be taking a look at a project, a prototype application I've been working on. It's for information management. I work in technical support. So, a lot of things that I do in my role that I have to, repeat a lot of menial small things. There's a lot of things that I think can be automated. It could be, meeting notations, emails, obtaining timestamps, screenshots, recordings, obtaining log files, performing log analysis, and creating reports based on all that information, or creating knowledge base articles. So I'll try to keep this not very dry, but it's a very dry topic. Um, so there we go. I've got a bit of a script here, so I'm going to go offbeat. What I want to cover today is how I would perform these tasks without the application and demonstrate how the application helps to automate the tasks. And it allows me then to remove a lot of micro stoppage, which is introduced from the repetitive menial nature of some of the tasks that I have to perform. And that kind of leaves me open to making errors, especially when I've got a lot of different things to juggle, and that can expose me to making mistakes. And I suppose there's a piece or a line that I've come up with here to kind of summarize it. And to reduce churn is to reduce frustration, increase efficiency, and helps focus on higher quality craftsmanship. Sounds like a fucking selling point to me. So the origin of the project, like a lot of good ideas, this one started with a problem, and that problem was, why don't I have more time in the day? I really would like having more time in the day. So I had an interest in using something called ImGui or ImGui. I didn't know much about it, but I wanted to try and create something I'd seen before, and I'd seen it used to make video game like launches, and some of them looked quite nice. And some small research I had done um, gave me the impression that it could be used for cross-platform development, particularly if I used it with C++, SDL2, and OpenGL. So I'm not really sure if that's entirely the case. I'm sure there's things that I would need to target for different platforms. But anyway, besides the point. I have a Windows machine. I don't have other machines to test it on. I don't have a Mac OS yet. And I don't really like using Windows subsystem for Linux. I think it's very cool. But I don't know. There's something about it. I'd rather just have it on its own system. Linux. So that's that. What I'm going to do is I'm going to, first of all, kind of just briefly look at the traditional workflow. If I had a task to perform, I would generally need to, create a folder, call it, this is my client's reference number. Did I spell reference? Who knows? So this would be like the job or the task. From here, I would need to, create notations. And what we'd have really is we'd have, what is wrong? Why are you complaining? Did you turn it on and off again. And silly things like that. But really, the point of this is to gather information from the client. And we want the information to kind of help us understand what it is we're trying to fix. And this is going to be our guiding compass. So this is, we need to obtain the information. What's wrong? When did it break? When did it start? Did anything change before you broke it? Have you performed these general troubleshooting steps? Has that modified the behavior? So on, so forth. So we would want to, save this. And there we go. We have notations. And these notations will evolve. And this is our first interaction with the customer. Interaction 1. And we might have interaction 2, which helps us understand more, and so on and so forth. 3, 4, 5. Okay, so we might get a little bit more. And this would happen on like another time, like so. So let's just say that this was today, and then this one was plus, I don't know, 6 days, 4 days in the future. We'd find out some more information. Plus 2 days, and so on and so forth. And hopefully you can kind of start to understand how the information we obtain, it grows. Okay. Hopefully we can get all the information here on the first day and we can fix the problem. Maybe there's some more work involved. We need to do some research. Maybe we need to do some development, investigation, get some, some logs from the machines or something like that. I don't know. Screenshots, recordings, blah, blah, blah. And every time we need to save it to make sure we don't lose the information. Because God forbid, well, what if we did something stupid and the information was lost? Like, I don't know, something could happen. I think Notepad on Windows 11, I think it prompts you for this. But if you close the application, no. Maybe I'm getting confused with a different application that has persistence. Anyway, let's just don't save. So, for whatever reason, we've lost some information that we had. Okay. The other thing we need to do is we need to grab, screenshots. And this opens up like a whole new thing of copying and pasting and making sure that things are in the right place. And as far as I understand, those things are on my desktop. Okay. So here on the desktop, we also have a bunch of screenshots. So let's just see the second. Today at what time? So 16. We just created these screenshots. So the second of the third, 4, 27, 34, 33, 31, 29, blah, 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 blah. You have to cut paste. Okay, and that would be maybe some screenshots that we've obtained of the problem that we're trying to look at and diagnose. Okay, so while we're trying to obtain notifications or notations on the problem. We're also trying to obtain screenshots, maybe a video recording or a screen recording of the event. Maybe we want to get some debug log information, and we got to copy and paste and do all these different things. And eventually we might get to a point where we're quite happy with the information we've got, and we need to create a report or acknowledge base article, or whatever you want to call it, knowledge transfer, whatever. And from here we'd have to maybe get some specifics, details from our notations. We'd have to say, okay, this is what is wrong. This is what changed. This is what should work. Look at this screenshot. So on and so on and so don't, and so on. Save. So there we go. That's all of that. So we've got one program, two application, or two notes, and so on and so forth. So what I've done is I've created this application, and this application works by basically automating a lot of these things here. We're gonna and this console here is just showing us some log output. So we have our case notes, and we might say something like come back. So we have our case notes, and we might say something like what is wrong? What happened? When did it happen? What has it affected? What device is affected? Are there other devices affected? Did you turn them all off and on again? Huh. Why not send them all back to the manufacturer to figure out? Okay, you would not say that last one. But this one gets a lot of hate, and I understand, but it's a very important thing to check. As we can see, the case is in an unsaved. It says unsaved changes, so it's in an unsaved. It's in an unsaved state. And we can see here in the console that it actually says something else. It says auto-saved note to C case manager temp data, blah, 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 blah. So if we take a look at the case manager folder, we see we have a temp data folder. We have a temp node. And this is our, we've only opened the application. So we don't know if we're dealing with something that's a problem yet or it isn't a problem yet. But we need to understand some information before we create, before we log this as an event that needs further investigation. So this temp node is, it is exactly what's going on in this. It's a persistent file So I can close this application, I can close this, and I can close this node. And this should still be there. Yeah. So we have a persistent file. And the file has not, just in case we need to gather that information, the file is somewhere that we can retrieve. So we haven't lost any information in error. Now, the other thing, when we open the program again, brand new, that information is lost. But let's just jump in here again. Yeah, so that information is lost. So that's a cool thing, right? Like we can have some type of persistence if we close the application, and if we open the application, we can start fresh. Maybe there's a way that we can modify this so that it's timestamped and we create different temporary nodes, but I think that's a little bit beyond what's required. Maybe it's something I should take a look into. In fact, let's add that onto the to-do list. Temp nodes persistence based on timestamp. There we go. Auto saved. Maybe. Maybe not. I don't know. Anyway. So let's what is wrong. What did you do? Did you hammer it with an EMP wave from a microwave? Brain fart that. All these things, did you turn it off and on again? Okay, and then we want to save the case. So we save the case and we give the case a name. And we want to say let's delete these. This is my special case. Okay. We notice a couple of things. Number one, we notice that the unsaved changes has disappeared. So we've informed the user that any information that is in this window has been saved. We also see that in the cases folder directory, we have a corresponding case name. Usually this would be like an ID number of some type. And if we open this, we have two files. So we have, if I open this up, we have saved a note data to this text file. So this text file really represents any information that was in here when the user selected save, and if there was no case active, it would prompt the user to create a new case. If there was already a case opened, it would just save that data to the open case that is active. And from here we can continue with more modifications. So this would be, I don't know, plus 3 days later after the original case was opened. So before I go ahead and save this, I want to point out how the application works. number one, we have these notes. And we can see the notes only go as far back as when the information was saved. We have the persistent, which is saved every 5 seconds. It's in memory and then it gets written to disk every 5 seconds. That could be changed, but it seemed like a good optimal thing. I don't know what the performance impact would be. Not yet. I haven't tested it. And we can continue doing this. This is some more data. Okay. And there we go. If I refresh, we got the persistent is still updating, but we notice that this file is not updating. So what we're going to do is we're going to save the case data. And we're going to save. We see in the top right, a new file has been saved. And we should see here in the console, there has been a new saved node. So we now have 2 saved nodes, and the 3942 will contain the up-to-date data. So you have the original data from the first event saved, persistent data saved on a second time, and then we have the persistent data, which is always represented here. So we could delete this, and we have some unsaved data. Now, in the persistent data, it's now reflecting this. But we still have a record, a historic record of any information. That just helps us in case we need to manage information. So let's save this. And now we see that we've saved the changes. We have 3 timestamped notes, and they all have different information. We can then create a new case. And this is just another case. Let's just save it. Some UI elements need to be reworked. This is another case. We save this. We have 2 folders. Okay. Now, something that's a bit lacking still is the ability to transfer cases. So let's go back to this is another case, and we have items somewhere else on the computer that we really want to store with this case. We want to add files and folders to the case which support our investigation. We want this to be easy and straightforward for the user. So we have some images here which I believe are going to be very helpful to our process. And we want to save these with the case. So if we just drag and drop it onto the case or onto the application, we see that the files get transferred straight to the active cases directory. And there we go. And again, and the great thing about this is that it works on files that are quite large. This is a junk data file I created. Options, properties, 2 gigabytes. 2 gigabytes. If we move this, boom, send over. If we have a zipped folder, send over. If we have a folder with files and will require recursive movements with the ability to move lots of folders and files contained inside a folder, we just click and drop, and the application takes care of everything for us. What I would like to demonstrate is that if we just save this now and we close it, there we have all of our data. And yeah, so one other thing I would like to demonstrate is how the temp data folder works as well, because obviously you might be in a situation where you're attempting to gather all of this information, but it's I don't know, it's you don't have an active case, right? So you don't know if you're going to have a case yet, but you still need to gather the information. And similarly, you want to add these files. I don't know, you might need this registration entry, a CV, and who knows, maybe you want to pull these things over and these. So it's important to note that the application doesn't copy the files, it just moves them. So right now we have this case with has not yet been saved. Okay. And we have dragged and dropped associated files for our potentially new case onto the app. We have now deemed a new investigation is required. Now this thing does not have spell check, so I don't know what I'm fucking up here or not. Save case. Okay, I'm gonna call this the best case ever. Okay, and then we just want to save, and what we should see is everything here in this window just pop, it vanished. And if we go over to our case manager, we should see cases, the best case ever, and all of the information relevant to our case is saved here now. And we can open any case we want now. The best ever case, this is another open case, this is my special case. We can just continue doing exactly what we want, save, and we can drag another file on top of here. Let's try and move grey goo. Okay, and that has been moved, and so what we want to check is if we go into special case, have grey goo. See how snappy and easy this is to work with. So there we go, some UI elements. There is some future things that I want to incorporate into this. I think it's a cool little thing. I know it's very boring for a lot of people, but it's software development, isn't it? It's not sexy. It's boring, but cool. One of the nice things about this is we'll just check out the task manager. One of the nice things is it doesn't really take up a lot of performance now. I don't know how much performance this really does use up. OBS is recording right now and it uses, less than 3%. This thing uses less than 2%. Its memory footprint is quite small. It is writing to disk quite frequently. But hey ho, that's the price of that. I don't know how big of an impact this is. I've previously tried to create an application. Let's try and open it. Let's File open. Project solution tool belt. Let's see how this one works. Start. Okay, this was a previous application I attempted to make. See how it compares. Where are you at, tool belt? Okay, so relatively small CPU hit. However, memory quite large. And this thing had a preview option. You could preview shit. We could choose displays to preview. Don't know if it updated them. It does update them. Problem is that that inflates the megabyte usage in memory up to like 500 megabytes. You can record, but the recording is not, how bad is it? Is it going to work? Oh, yeah, there was some gotchas. Create file, create project, test project. Let's create a test. Start recording. I think we broke it. Okay. So CPU usage is not bad. It is using FFmpeg. 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 Whatever. But the performance is quite good. Especially quite good compared to the ImGui example. ImGui is an immediate UI, as I understand it. So what that means is it's more akin to a video game. It draws its frames every second, and there is an update loop which is consistently running in the background. Whereas, as I understand other UI interfaces, they read from a single source of truth. I don't know how else to explain it because I barely really understand how to explain it. But essentially, in the concept or idea, I think, of the immediate UI interface is that there's two sources of truth. There is the loop information, and then there is the UI information, and both of them need to be, I don't know, something together. And with the more traditional UI implementations, there is just a file somewhere, and that's the single source of truth. So yeah, I don't know how to explain it, but yeah, more CPU. Yeah, so more CPU for ImGui, which on my system is not really a big deal because the system has quite a lot of fucking it's got a lot of grunt there to make things work. But if you're on like an APU system for a business laptop that's been issued to you by a mega conglomerate or whatever that doesn't want to give you a more powerful system, because let's face it, APU systems are quite cheap and quite disposable in terms of monetary costs compared to something that might cost 3 or 4 times the amount of money for better performance. But then you've got better performance. But yeah, that's just... So there you go. That is my application. Stop recording. I don't even know where you go anymore. Load template. Oh yeah, this one could load templates and stuff for different reasons. Okay. I don't know where those get saved anymore. But that's it. That's my project. That is my ImGui test case. If you like this idea, if you'd like to see more, let me know. I'll create some more videos and I'll provide an update. And this is kind of rambled on for 30 something minutes. I don't think I'm going to be bothered about editing it. Yeah, there you go. Peace.